Bismillahirrahmanirrahim. This video is about Laplace transform, article number 14.6 from Mr. Hayt's book. In this video, I'll primarily be solving these two problems, practice problem 14.11 and end chapter problem number 48. So let's see the practice problem 14.11. Question is use Laplace transform method to find IT in the circuit. Now this circuit is given in the time domain, but to find current we'll move it to Laplace domain. That makes it easy to solve. So let's convert it into Laplace domain, and for that we'll be using this transform pair. We have the from time domain to Laplace domain, delta t becomes 1, ut becomes 1 over s, and e raised to the power minus at ut becomes 1 over s plus 1. And to find from Laplace domain to time domain, we just go inverse of this. So let's first of all convert the circuit. So our circuit delta t will become 1, delta t is 1, so 1 plus ut is 1 over s, so 1 over s. So this has become the voltage source in Laplace domain, and the resistor no change inductor will become 0.2 s. And now we can find the current Is. It has become Is. So we'll find Is by simple Ohm's law, voltage divided by the impedance. So Is is the voltage divided by impedance, 4 plus 0.2 s. And we'll just do a couple of steps to simplify it. 0.2 is written as 1 over 5, and then further simplification, manipulation. So this is the final shape that we have, 5s plus 1 divided by s into s plus 20. And now we'll take help of partial fraction to solve this. So Is is this, we can write it is equal to a divided by s, one of the terms in the denominator, plus b divided by the other term, s plus 20. Now a and b are unknown, so we'll have to find the values, and for this there are two methods. One is the residue method and another is the algebraic method. I prefer residue method, so we'll follow that. Okay, residue method, to find a is equal to, we multiply this s with the is, so s is, and the denominator equal to 0 becomes the condition. So s is equal to 0, this is the condition. And now we'll plug in the value of I from here. So s multiply by the value of I, and then s cancels, so it will become like this. The condition still s is equal to 0. And now we'll plug in the value of s is equal to 0, so this will become 0. This term will also become 0, so we'll get 5 over 20, which is equal to 1 over 4, which is equal to 0.25. So this is the value of A. Same way, we'll find the value of B. We multiply with the denominator of B, so multiply with the denominator of b is, or this value of is, and the condition now will be s plus 20 is equal to 0. That means s is equal to minus 20. So this is the condition. These two terms cancel, so we get this form. Plugging in the value of s is equal to minus 20, we can find the answer to be 4.75. And so Is is equal to, plugging in these two values, Is is equal to 0.25 s divided by plus 4.75 s plus 20. And from here now we can move into the time domain. 0.25, 1 over s is equal to ut, 1 over s is equal to ut, and 4.75, 1 over s plus 20. So s plus will follow this. So this will become e raised to the power minus 80. Our a is 20, so e raised to the power minus 20t ut. So this is the answer of the first part. Given in the book is taken ut common from both. So this is the final answer. Okay, now let's solve end of the chapter question number 48. It's exactly the same circuit, only the voltage parameters have changed. So the voltage is given already in S domain or Laplace domain. So all we need to convert this in S domain and find the current. Again, we'll take help of this chart. And so the circuit in S domain will look something like this. The voltage source remains same, only the inductor changes to 0.2S as we discussed in the previous example also. And find the current now, voltage over impedance. So voltage, this voltage divided by 4 plus 0 to S. And solving this as we did in the previous case, this is the final answer. And now we'll take help of partial fraction to get the separate terms. So now since there are 3 terms in the denominator, so we'll have 3 unknown variables a, b and c. And I'm sure you can follow now that a is divided by s, b will be divided by s plus 1 and c will be divided by s plus 20. And so we were here. Now from here we'll take the help of residue method, and in residue method to find a we multiply by s, to find b we multiply by s plus 1, and to find c we multiply by s plus 20. So just follow the steps as we did in the previous slides, exactly same. S into is, s is equal to 0 is the condition. Putting the value of is, this one cancelling s and s, so we get this term. S is equal to 0, putting the value of s is equal to 0, so this becomes 0, this becomes 0, this becomes 0. So we get 10 on the top and 20 at the bottom, and the value of a is 0.5. Similarly, for b, we now multiply by s plus 1, and the condition will become s plus 1 is equal to 0, that means s is equal to minus 1. Solving, putting the value of s is equal to minus 1, we get the answer of minus 0.263. I'll recommend that you pause the video and you solve yourself all these steps. And same way, the value of c comes to be minus 0.237. So the current I S in S domain will look now like this, plugging in the value of A, B and C. So this is the one part of the answer, and now we go to the time domain, and for that we'll now take again look at the table. So like here 0.5 1 over s, so 1 over s means ut. So this will become 0.5 ut. Same minus 263 e raised to the power minus t ut, because a is 1 here and here a is minus 20, so e raised to the power minus 20. So this is the answer in time domain. We take common ut from all. So this is the final answer. So I hope this gives you an understanding as to how to solve this type of a problem. Thank you.